Number 4, we are required to differentiate this function with respect to x. And again, this is a quotient of two expressions, so what we need is product. So we'll have y being equal to 5x minus 1 multiplied by 3x squared to the power negative 1. So that's a product of two um, functions. And then we can be able to apply product rule. So dy over dx will be equal to 5x minus 1 multiplied by the derivative of 3x squared to the power negative 1. And then here we have 3x squared to the power negative 1 multiplied by the derivative of 5x minus 1. And then here we have 5x minus 1 multiplied by outside we have 3x squared to the power negative 2. Inside will be 6x by chain rule. And then here you have just the same expression multiplied by 5 because the derivative of 5x minus 1 is just 5. And then we can simplify this. I'll first of all leave the negative out. So if you multiply 6x by that, that will be 30x squared minus 6x multiplied by 3x squared to the power negative 2 plus 5 into 3x squared to the power negative 1. Then you can bring back the negative in, so that will be 6x minus 30x squared multiplied by 3x squared to the power negative 2 plus 5 multiplied by 3x squared to the power negative 1. So again, I'll just leave my answer that way. But again, you can simplify it further depending on what the question is asking you. If it's asking you to show that this is equals to that, then you can simplify it further. All right. Last question, number 5. Find the equation of the tangent to the curve at x is equal to 0 and y is equal to 1. So first of all, we need to rewrite this as a product of two functions. So that will be y is equal to x squared plus 1 multiplied by x plus 1 to the power negative 1. If you bring the denominator up top. So dy over dx will be equal to x squared plus 1 multiplied by the derivative of x plus 1 to the power negative 1 plus x plus 1 to the power negative 1 multiplied by the derivative of x squared plus 1. And this will be equal to x squared plus 1 multiplied by, again here, apply chain rule, negative 1 x plus 1 to the power negative 2 multiplied by 1 because the derivative of the inside is just 1 plus x plus 1 to the power negative 1 multiplied by the derivative of the inside here will just be 2x. And then you simplify the resulting expression. What we can do is just simplify that part. So this will be equal to negative x squared minus 1 multiplied by x plus 1 to power negative 2 plus 2x into x plus 1 to power negative 1. And that will be the resulting expression. So basically, what we want to find here is the gradient of the tangent at x equals to 0. So, or at x equals to 0, the gradient of the tangent will be equal to, we substitute 0 in place of x in the gradient function. So that will be 0 minus 1. This will be 0 plus 1 to power negative 2 plus 0, because this is just 0 multiplied by everything will be 0. So basically, this, the reciprocal of 1 will just be, you know, I mean, if we bring this, this is negative 1, and this will be, so this is similar to negative 1 over 1 squared, which is just negative 1. So that will be equal to negative 1. So the gradient of the tangent at x is equals to 0 is 1. Now we can be able to find the point slope, the equation of the tangent using the point slope formula, or alternatively, since x equals to 0, we know that that's the y-intercept, so you can just write the equation. But I'll just use the point slope formula because, you know, that's a general method that can be applied in any other question. So the point slope formula states that y minus y1 is equals to m into x minus x1. Now in our case, m is equals to negative 1, y1 is 1, and x1 is 0. So y minus 1 is equals to m, which is negative 1, x minus 0. And that implies that y will be equal to negative x plus 1. So basically, the equation of the tangent to the curve at x equals to 0 is y is equals to negative x plus 1.